Continue with question number 6. A chord of a circle of radius 15 cm subtends an angle of 60 degrees at the center. Find the area of the corresponding minor and major segment of the circle. Clear? And we have to use pi to be equal to 3.14, and then root over 3, the value is 1.73. So you can see from here the radius given, the theta given. Alright, so this is a diagram that we'll be referring to. Clear? So how do you find the area of minor sector? Very simple. Area of the sector, right? Area of the sector minus area of this triangle. So when I subtract these two, I'll get the area of the minor segment. Okay, so there is the first thing that we'll be doing. So you can already see area of sector, that means minor, right? OA PB. Okay, so remember we're going to find this minor sector first. Clear? Then what is the formula? Pi r squared theta by 360. Pi they told us to use 3.14. You can already see radius is given, so 15 to 15, theta is 60, divided by 360. So let's start the division. 0 0, then 6 1 is 6, 6 6 are 36, right? Then 2 3 is 6, then 2 1s are, then 2 5s are 10, and then 2 7s are 14, right? Then 3 1 is 3, 3 5s are 15, which means I'll be having 1.57 into 5 into 15, which if you multiply, you're going to get the area of the sector. So remember the sector is that pi, right? This area, this whole area. How much are we getting? 117.75. Okay, now the other thing, the next way to do is find the area of this triangle OAB. So let's do it in the next. So alright, so like the previous question, we have already done this, right? We try to prove that it is an isosceles triangle, right? Why? Because remember they've given us two sides to be equal. When two sides are equal, even this the two angles are equal, which means this triangle OAB is an isosceles triangle. Alright, now the last time, what did we do after that? We tried to prove that this triangle is an equilateral triangle, right? And after we put the area of equilateral triangle, root over 3 by 4 a squared. That was how we solve, right? But now there's another way of solving it. Okay, we'll just put directly the formula for area of an isosceles triangle. What is the formula? Half times a squared sine theta. Okay, so remember you can use the previous method, or you can even use this. Clear? It's up to you. So the formula to find the area of an isosceles triangle is half times a squared sine theta, right? And sine theta, remember theta is how much? 60, and then a squared is the side, right? And you can see the side is how much? 15, right? And because it is square, you can say everything 2 times. Then sine 60 is, what is the value of sine 60? Root 3 by 2, trigonometry. Clear? All right, then if we're done with that, I can divide this, right? 2 1s are, 2 7s are 14, 2 5s are 10, same thing again, 2 1s are, 2 7s are 14, then 2 5s are 10. And what is the value of root 3 that they have given to us? They told us, right? 1.73. Clear? So now when you multiply these three, 7.5 into 7.5 into 1.73, we're going to get the area of the triangle to be equal to, that means this whole entire region to be 97.3112. Now in order to find a minor segment, I just have to subtract, right? So area of the minor segment equals area of the sector, right? This whole sector minus area of this triangle, then I'll get the minor segment. So that's what I'm writing down the formula, right? Area of sector we got to be 117.75, and then area of triangle or AB we just got now 97.312. So simple, just subtract, and then we're going to get the area to be equal to 20.438. Now the last part, the second part, they told us to find the major segment, right? So when you look at this diagram, you can see the major segment is this region, right? How do you find area of the circle, right? The whole circle minus area of this minor segment, and I'll get this major segment. So area of the circle minus area of the minor segment. Area of the circle, the formula is what? Pi r square. So pi, the told us to use 3.14, radius is, we already know, 15, right? So 15 and 15, and then area of the minor segment, we just got it there, 20.438. So when you multiply these three, you'll get 706.5 minus 20.438, and you subtract these two, and that's how we're going to get the area of the major segment to be equal to 686.06 centimeter square.